So again, today we're going to continue where we left last time. And let me look at the, I'm not sure about, so again, if you have any question about what we did so far, again, you can ask. We started the derivative formulas, and I think we went through the power rule, the constant rule, also the coefficient with variable rules, and also we went through addition. Actually, that's where we reach now. So today we're going to continue with the concept of addition, subtraction, multiplication, division of derivative. So first I'm going to just do a little bit review on the 9-3. Again, 9-3, we studied about the rate of change. And we said the whole concept of derivative is based on rate of change, which is the same concept as slope, find a slope of. So this is the formula again to find the rate of change. We may have a function and we want to know the rate of change of the function from interval A to B. So we are going to plot the value of B into the function to find f at B, the value of A into the function to find f at A. Then the denominator will be B minus A. Or the same thing as we find a slope, we can say f at A minus f at B. Then the denominator will be A minus B. And the diagram here again explain. The reason I'm going through this again, just a short review of the quiz. So we should know how to find rate of change and also the concept of instantaneous rate of change, which is velocity. Normally they will give us one particular point, which will lead us to find the actual slope of the values. And this is where our limiting process concept came from. So if I have a function f at s is 96 plus 64x minus 16x squared. I want to find the average rate of average velocity from 1 to 1 plus 8, 1 plus h. So this is more or less like finding the average rate of change. It will be f at b minus f at a over b minus a. So b will be 1 plus h, a will be 1. So I'm going to plug 1 plus h anywhere I see x in the function, then solve it. Then I'll put 1 in anywhere I see the function, solve it. I find the difference of it. Now 1 plus h minus 1 will give me h because plus and minus 1 will cancel. So finding the average velocity from beginning of A, which will be 1, to B, which is 1 plus h, is the same as finding average rate of change. But if they say we should find the instant velocity, they will give us a particular point. So still I need to find the function, the derivative of the function, then I'll plug 1. So that's the solution here. We find f at 1 plus h minus f at 1. Then when we get the solution here, we divide by 1 plus h minus 1. And this will be our result. Now with this function, I can find the instant rate of change. I will use the limit. The instantaneous velocity, v, is the limit of average rate of change at h approaches 0. So we find the limit of it. And that will give us the value here. Now, since the expression here, there's no x variable, then the answer will be 32. But when we look at the question, they say we should find the instantaneous velocity at s equal to 1. But since we don't have no x, then that will be our final answer. So that leads us to finding the derivative of a function. These are just the symbols we can use, as we said. And also, if we have a revenue function and they say we should find the marginal revenue, it's a rate of change of the revenue. So we have to find the derivative of the revenue. So marginal revenue is the same as finding the derivative of a function. So that leads us to the limiting process. I have a revenue to find the marginal revenue to be Rs plus H, R at X over H, same as our limiting process formula. So we have a function, R at X. The process is the same as, so to find the marginal revenue, it means I have to find the revenue of the function. And that's where we use, as we said earlier, this function, we use it to find any revenue of, not any revenue. This is the revenue function. So we use it to find any derivative. So here we are looking for the derivative of the revenue or marginal revenue. So this is a derivative formula, as we said earlier. So here we find the S plus H minus X divided by H. Plug in, substitute, yes.
Sorry to interrupt. We have somebody in the weight room. They said, can you let them in?
No. I don't see the person. Doesn't. I can't. If it's in the waiting room, I should see it from here. But let's see. Let me stop sharing my screen 1 second then. Well, I don't see anybody in the waiting room. I can't see anybody. Okay, now the person show. Okay, now. Okay. So as we said again, this is using the limiting process to find the derivative of the function, which is the same as, again, finding the marginal revenue. So again, same formula. So if no question again, I'm going, this is just again the review to get a concept for our first quiz. And we discuss about this using the limiting process again. So again, today we continue with the 9.4. We started the 90, again, this is 9.3, rate of change and instantaneous value. And then 9.4, I think we started with the power rule already. But we can just go through very quick. So this is the power rule, which we covered last week. We say if we have s to the power n, derivative of this function will be n times x raised to the power n minus 1. So which means we multiply the exponent by the coefficient of the variable and we subtract 1 from the exponent. So we went through, actually this is the formula again, we went through last time. Let's just do a quick review on the questions here. So yeah, they say we should find the derivative of u at s. S is, the function is s raised to the power 8. So the answer here will be 8 times 1, which is the coefficient. Then exponent will be 8 minus 1. So the answer will be 8s to the power 7. We can look at the answer. So 8s to the power 7. The b also the same thing. We get 2 by 3 minus 1, which will be our exponent. And the coefficient will be 2 by 3 times 1. So we get 2/3 q raised to the power negative 1/3. Since the exponent is negative, we can bring it down to the denominator. Then we change the exponent to positive. So the answer will be 2 divided by 3 times q to the power 1/3, or cube root. And we can see the answer here. So we have 2/3 q 2 by 3 minus 1. Because the coefficient is 1, so 2/3 times 1 is 2/3. And we subtract 1 from the exponent, so it will give us negative 1/3. To change the exponent to positive value, we find the reciprocal of the value, so it will be a denominator. Q. Also, the square, we said the square root is the same as half exponent. So square root of t is the same as saying t raised to the power half. So to find the derivative of this function, I will multiply again half by 1, which will give me half. Then I'll subtract 1 from half, which will give me negative half. So we're going to get something like this. So this is our solution. Then since the exponent is negative, we can bring it down to the denominator and change the symbol to positive, the exponent symbol to positive. So we get 1 over square root of t, or t to the power half. And next question is the same concept also. So we have 1 over square root of t is the same as writing t to the power negative half. So we have negative half minus 1, which will give us negative 3/2. And we multiply by negative half by 1 for the coefficient. So the coefficient will be negative half, because negative half times 1 is negative half. T to the power negative 3/2, because minus half minus 1 is minus 3/2. So we can also bring the t down and change the exponent to positive. So we get 1 over 2 times square root of t cubed, which is the same as t to the power 3/2. Then we shouldn't forget the negative also, it's negative half. We also went through the derivative of a constant value, and we said that the derivative of a constant value is always 0. And here we were able to prove it. If I have a constant value for f at s plus h, then it will be c. C is any constant value. F at s will give me c. So if I have these two functions, give me constant value. A constant value minus the same constant value will give me 0. 0 divided by h will give me 0, or 0 divided by any value or any variable always will give us 0. So the derivative of a constant value is always 0. Now, derivative of a function, a variable. This function here have a variable x by times c. So c will be like a coefficient. You still, whatever the function rule is, you still apply the rule. If there's a power rule, you apply it. If it's addition, multiplication, whatever it is, you apply. Then whatever answer you get, you multiply by the constant value. So that's why we have c times u at x. So we find the derivative of u at x. The answer we get, we multiply by c. So that's the rule here. If I have f at s equal to c times u at x, the derivative of f at s will be c times the derivative of u at x. So we don't touch the constant value. We leave it. Then whatever we get after the derivative of u at x, we multiply it to the constant value. So here we say the coefficient rule says that the derivative of a constant times a function is the constant times the derivative of that function. So we have example here, f at s equal to 4x to the power 5th. So this means I will multiply the 5 to the 4. To find the derivative of s to the power 5, it will be 5s to the power 4. So I'll get 4 times 5. So later our answer will be again 20s to the power 4. Please, let's do our best to come to the class early. We just assume we are in the campus also. This is mostly from home. I intentionally wait 2-3 minutes, 5 minutes late. Hopefully everybody's around. Then we start. I even started like close to 10 minutes late. So please try to be in time. And maybe I'll start to take attendance. So again, the coefficient with constant, you find the derivative of the function first. The answer you get, you multiply by 4. So derivative of s to the power 5 will be 5 times s to the power 4. Why? We know the power rule. Multiply the exponent by coefficient 1, then subtract 1 from the exponent. So it will give me 5s to the power 4. Then 5 times 4 will give me 20. The same thing apply here also. If I have half t square, remember this t is a numerator. So I'll bring the 2 to the front and I'll subtract 1 from the 2, which will be the exponent. So my answer will be 2 over 2 or half times 2t. But since we know 2 divided by 2 will give me 1, and that's what we have here. Our final answer will be t. So here we have t. The same thing applies to this last question. Q is the denominator, it's in denominator, and it's a square root. So we can bring it up and have q to the power negative half. And that's what we have here. We still have our 5, we didn't touch it. We just bring the q up, square root of q up, which is q raised to the power half. So the derivative of q raised to the power half will be, yes, raised to the power negative half. So it will be negative half times q to the power negative half minus 1, which will give us negative 3 by 2. And that's what we have here. So later we multiply the 5 by half, which will give us 5 over 2. We change the exponent back to positive, so we bring the q down. So we get q 3, 2. Half is square root, then 3 is cube here. So final answer will be negative 5 again. And I think this is where we reached last time, last week, Thursday. So I want to know if we have any question. Again, the quiz will be on.
Yeah, Professor, you said it's fine to leave the answer like that, right? Like we don't have to simplify it to the final one, right?
No, yeah, you can. It's up to you. You can leave the answer as positive or negative. That's fine. The exponent positive or negative, that's fine. But as we said earlier, our questions will be multiple choice. So if it's in the campus, normally mathematics, no multiple choice. You have to solve the problem. But I try to make it as best as we can. So I'm not there. We are not there. So the whole idea is, if it's a multiple choice, maybe you see this answer. You may not see this answer. So you should know this is the same as this. Wait for a few seconds if we have any question before we continue with a new material. So this is where we reached last time. So now let's start with the derivative of the sums and differences. It's very straightforward. If I have a function f at s equal to u at s plus v at s, here we are assuming u and v is a function adding together. For example, we have two polynomials adding together. So all we need to do, we're going to use the rules that we have learned so far: power rule, constant rule, coefficient with variable rules. We are going to use it to find the derivative of u at x and then derivative of v at x. Then, if possible, we combine the like terms together. So if two terms are the same, we can combine. Sometimes when they give you a function, to find the derivative of a function, u at s plus v at s, and there's a like terms in the function, if you like, you can combine the function first before you find the derivative. You still get the same answer. Or if you can reduce the function, then reduce the function first before you find the derivative, you get the same solution. So same thing applies to the difference. So I have u at x minus v at x. If there's any like term, I'm going to combine it first. Or if I can reduce it, I'm going to reduce it. Then later on, I'll find the derivative of u at x and the derivative of v at x. Then find the difference of the two, if there's any like term. So let's see some example. We can see y equal to 3x plus 5. We already know the constant rule. And we know the rule for coefficient with a variable. So x means the exponent is 1. So I'll bring the 1 to the front of x. And I'll subtract 1 from 1. So I'll get 3 times 1x to the power 1 minus 1. And s to the 1 minus 1 is 0. So we know that any variable or any value raised to the power 0, the answer is 1. So I'll get 3 times 1 times 1. So that will give me 3. We know the derivative of a constant value is what? 0. So which means y equal to 3s plus 5. The derivative of this function, the answer will be 3. Now we come to the second b. We have f at s equal to 4s cubed minus 2s squared plus 5s minus 3. I look at the function first, the variables, if I can combine any like term. When we look at this function, we cannot combine any like term. We cannot. So apply the first one, we have a power rule, second one power rule, third one power rule. The last value is the constant rule. Remember, this is with a coefficient. So we multiply the 4 by 3. So we get 12x. We subtract 1 from the 3. So it will be 12x squared minus 4x, because 2 minus 1 is 1 and 2 times 2 is 4. So it will be minus 4x here. And this is same as the previous question, 3x and 5x. The answer will be 5, because 1 minus 1 is 0. S to the power 0 is 1. 1 times 5 is 5. So we get 5. The derivative of a constant value is 0. So our answer will be 12s squared minus 4x plus 5. So you can see that whether you are finding the difference or the sum rules, we are still using our previous 3 rules, because we know every function may have an exponent, may have a coefficient with a variable, and may have a constant value. So far we know how to find the derivative of a constant value, how to find the derivative when the variable is raised to a power, how to find a derivative when we have a variable with a coefficient or with a power and coefficient. So our previous rules we learned, we apply them here. And the sum and addition basically just to perform those operations. So let's see the solution again. So the rate of y will give me 3 times 1, as we said, because s is 1 minus 1. Anything raised to the power 0 is 1. The derivative of a constant value is 0. So the answer will be 3. Then let's go to the second one. The second one, even they explain here to us that the rule regarding to derivative of sums and difference of two functions also apply if more than 2 functions are involved. So if I have 20 functions, or here we have 4x cubed minus 2x still apply. So we have 4 different. So we solve them separately as we said. So the answer here will be again 12x square. We get final answer. Let's write see that 12x squared minus 4x plus 5. Why? We almost use all the power rule. Let's go to the original function one more time. I will get 3 times 4, so that is 12. 12x, 3 minus 1 here is 2, so 12x squared. 2 times 2 is 4. 2 minus 1 is 1, so it will be 4x. The exponent will be 1. Always remember the exponent, you subtract 1 from it. Even if the exponent is 1, like 5x, it will still be 1 minus 1. That's why the answer here is 5, because it will be 5 times x raised to the power 0. X raised to the power 0 is 1. So the answer will be again 12x squared minus 4x plus 5. Again, you can see that addition and subtraction, we are using those 3 rules we learned earlier. Every function may have a power, the variable may have a coefficient, the function may have a constant value. And we know those 3 already, the formula rules. So if no question, then we continue. Well, I have a student late for 30 minutes. I think I will put a new rule here. If you are late more than 15 minutes, I will not admit you in the class no more. We're going almost halfway through the class, and now this is online, and I'm hoping that we are all at home, or even if you're at your workplace. This is online section, so you know when to log in. If you know you can't make it, just watch the video. I'm recording the lectures. Please try
Professor,
to come. Yes. Yeah, go
I
ahead.
had to try a couple links before it said that I was able to get into the class.
No, as I said earlier, the link that I posted in the announcement, the last link, is the same link we are going to use every day or every section to the end of the semester. I set it to end at 1st June, so we're even going to the end of the semester.
Okay, because at 8:30 it said that there was no like meeting to join. It said waiting for the host.
Oh yeah. Then again, as I said, I waited for a few minutes to make sure everybody will be around. So I log in like 8:32, 8:33. So if I didn't log in, you cannot come in. I have to log in first, so maybe that's why. So next time I'll even try to log in maybe 5 minutes to 8:30. Then I'll wait for at least 5 minutes more to make sure everybody's in before we start.
Professor, I have a question.
Yeah.
Why do the integers turn into zeros?
Yeah, because the derivative of a constant value is 0.
Okay.
That's the rule. We can, let me see if I can go to that slide again. And the show. So the previous 9.3, oh, actually it was this slide, what I'm doing. Let me make sure if it's in this slide. I think this slide is where we started the derivative. Yeah, okay, it's right here. So derivative of a constant is always 0. 0. So
Okay.
anytime we have any constant value in the function, the derivative of it is 0 straight.
Okay, thank you.
Yeah. So derivative of 5 is 0, derivative of 3 is 0, always. Then if the exponent is 1, then it will be only the constant value. So for example here, derivative of 5x will be only 5 because the exponent of x is only 1. So it will 5. 5 times 1 is 1. 1 minus 1 is 0. X raised to the power 0 is 1. So anytime we see a derivative of a variable, the exponent is 1, just write the coefficient. So derivative of x will be 1 because x, the coefficient of x is 1. But derivative of any constant value, 1,000, 150 is always 0. So again, here we say for all points on the graph f at s equal to s cubed plus 3s squared minus 45s plus 4, where all the tangent line is horizontal. So we are going to find all the possible points on this graph where the tangent line is horizontal. So when we say a tangent line is horizontal line has what? A slope of 0. So when we say a tangent line is horizontal, it means the slope is 0. So what will happen is that we're going to find the desired points after we solve the derivative of the function. Again, this is calculus. The function, this function is not a linear function. So which means we are going to have a function non-linear, then we're going to draw a horizontal line. So where the graph, the point where the straight line and the nonlinear graph intersect, that's what we are looking for. So here, when we find the derivative of the function finish, we equate it to 0 and we find the point for the x, the intersection of it. If we get the x, we can get the y also. So let's go and find the derivative first. So the derivative will give me, I have 3 here, so it will be 3 times x to the power 2. You subtract 1 from 3, you get 2. Then we have the coefficient 3 times 1. The coefficient is 1, so it's 3s squared. Here we have the exponent 2, so 2 times 3 is 6. Then we subtract 1 from 2, left with only 1, so we get 6x. Then 45x, we have exponent 1. 1 minus 1 is 0. S raised to the power, any, again, as we said, any variable and value raised to the power 0, the answer is 1. So we get only 45. Then the derivative of any constant value is 0. So derivative of 4 is 0. So our answer will be 3s squared plus 6s minus 45.
6x is from the 3x squared, right?
Yes, because the rule said we multiply the exponent with the coefficient. So 2 times 3 will give me 6s. Then we always have to subtract 1 from the exponent to get a new exponent. So 2 minus 1 is 1. So instead of writing 6s to the power 1, we normally write 6s. Like here is 3. 3 minus 1 is 2. So that's why we have square. And we bring the 3, the coefficient is 1. So 3 times 1 is 3. So that's why we bring the 3 here. Wait for a few seconds if we have any question. Okay, let's keep going then, if no question. So now, remember the question said we should find all the points on the graph. So now we know the derivative of the function. We are going to equate 3s squared plus 6s minus 45 equal to 0. Then we've solved for x. So this equation this equation is a quadratic. It's a quadratic equation now. So if you like, if you can factorize it, fine. If you cannot factorize it, then use the quadratic formula. So here we decided to factorize it. 3 is common. We take 3 out. Then we have s squared plus 2s minus 15. So let's see if we can get two values that when we multiply, we get minus 15. When we combine, we get plus 2. I think it will be 3 and 5. And 5 will be positive. So positive 5 times negative 3 will give me negative 15. Then combining positive 5 and negative 3, I'll get positive 2. So it will be 3 and 5. So that's it here. We have plus 5 and negative 3. Again, if you don't want to factorize, it's up to you. You can use the quadratic formula, minus b plus or minus square root of b squared minus 4AC divided by 2A. And then in this case, A will be 3, B will be 6, C will be minus 45. And you get the same answer. Either use the quadratic formula or you factorize it. So that's what the earlier time I said, factorization and elimination of a function and solving a function to reduce the function is very important in our derivative here. So we know 3 will be gone. S plus 5 means S equal to negative 5. S minus 3 means S will give me positive. So we have 2 points. When S is negative, when we draw the horizontal line, it's going to touch 2 places on the graph. It will touch when S is negative 5, and it will touch also when S is positive 3, the horizontal line. Okay, so if no question, we keep going. So as we said earlier, if I know the negative 5 and 3, I can find the vertical where it touches. But again, this is horizontal line, so we're going to get the same value. So here we say the y coordinate of these S values come from F at S. The desired points are negative 5 and F at negative 5. It will give me this. Then at 3, F at 3, it will also give me this. So those are the 2 points. And this is how it looks. So when we plot the graph, you can see the horizontal tangent, the mass, and the second one. So this is the point we are looking for. The tangent point touches 2 places. So next we move to marginal revenue. And as we said earlier, marginal revenue is the concept of, again, finding the derivative, rate of change of the revenue derivative. So here we say the marginal revenue is used to estimate the change in revenue caused by sales of 1 additional unit. So kind of rate of change. But the rate of change is based on when you sell more units, not on time. Otherwise, for example, a company can have a revenue. They may sell. Let's say a store may sell something $100 at 9 o'clock, and maybe the whole day they will never sell no more. So the rate of change will remain the same. The only time there will be a difference in revenue is when they make additional sales. So the rate of change doesn't go with time, like our previous example. Marginal revenue, you find it a change of a revenue when you sell 1 or more items more. You sell 1 or more items. So we have a question here saying that if we have a company or a manufacturer of a product knows that because of demand for its product, they know their revenue is this. This is if the company sell an item, S will be the products. If they sell S amount of items between 0 to 1,000. So it should be somewhere between 0 to 1,000. This will be the revenue they are going to generate. Now we say S is the number of units sold. Now the question says we should find the marginal revenue at S equal to 500. This means I'm looking for the marginal revenue. So the first thing I will do, I'll find the derivative of the revenue function. Then I'm going to plug 500 into the X value. Then that will give me the marginal revenue. Now the next question says find the change in revenue caused by increasing in sales from 500 to 501. Now, instead of us finding the marginal revenue, the B saying that plug 500 into this function and find the revenue. Then plug 501 into the function and find the revenue. Then you find the difference between the two. You will see that the difference between the two is the same as finding the marginal revenue value, since it's 500 too. So that's why we said earlier that rate of change is same as derivative. So if I plug 500 to this value, 501 to the function again, the two answers I get, when I find the difference, I will get the same thing if I find the marginal revenue at particular the rate of change. So let's see how this goes. So first we find the derivative, and the derivative here will be, since exponent is only 1, it will be 1 minus 1, which is 0, 1 times 1,500, which is still 1,500. S raised to the power 0 is 1. So we get 1,500 minus, we multiply 2 by 0.02. That gave us 0.04. Then we subtract 1 from 2. So we get 0.04x. So I'll wait for a few seconds if it's okay. Go back once. Okay, so if no question, let's skip. So now we know the derivative of the function. We just have to plug the 500 in. So 500 times 0.04 will give me 20. So later our answer will be $1,480 per unit. So first find the derivative, and second, the marginal revenue at S equal to 500, we substitute 500. Now B, so the answer here means we can interpret this to mean that the approximate revenue from sales of 501 first unit will be 1480, because at 500 the next 500 first. So the same concept here. This time we find the revenue. We use the actual, you can see that we are using the actual function. We are not using the derivative. But when we do that, we should get the same answer. The answer will be 1479. Here we got 1480, I think. Let's see. Yeah, 1480. Yeah, but it's the same 1479.8. Actually, 1479.98. So it's roughly 1480. So that's what I was mentioning here, that when we look at the question, to find the marginal revenue at S equal to 500, it means what would be the difference of the revenue when you sell your next item, 501 item. It's the same thing here. Find the change in revenue caused by this function. So if I have 500, I'll put the 500 into the original function. Then I'll put the 501 into the original function again. Then I'll find the difference. The answer is the same as if I find the marginal revenue at 500 beginning. The rate of change to the next will be 500, 501. If I want to find the marginal revenue at 502, then I'll find it at 501. It's because 501 will give me the next changes to 502. So that's why here we find the derivative of the function first. Then we plug in the 500, and that will give us the marginal revenue, which is the 501 item we are going to sell. The marginal revenue will be changed to this per unit. So 500 to 501, this is what we get. Now, if I don't want to do it that way, then what I will do, I will use the original function to find 501 and find 500. The answers you get, you find the difference of the two minus, and that will give me again rate of change from 500 to 501, which is 1479.98. It's the same as finding the marginal revenue at the beginning point, which is 500. You get the same answer. So that's what they are telling you. Notice that the marginal revenue at S equal to 500 is good estimate of the revenue from 500 first unit. Because when we do it originally, we get the same, almost the same value. So that would be the conclusion of 9.4. And our quiz will end at 9.4. In our quiz, we will not go through the product unit, but that's what we are coming to do now, the product and division. So we can see that in the whole concept, addition, subtraction, it's like you should know the power rule, the constant rule, and the coefficient of function rule. Those three rules, you should know it. Then you apply it to the addition, subtraction. But when you come to product and division, there's a little bit trick. We have the original formula, and we have to use the original formula that they gave us before we apply the derivative law. So that's what we will go through now, the product rule and the quotient rule. So I don't want us to have this quiz on Thursday with these materials because it's like we have only one, especially if this is the first time we are seeing it. It's like you have only 1 day, 1 or 2 days to study it and take a quiz on it. So this material will not be in the quiz, but we need to start it. So product rule, I'll go straight to the formula. So we can see how the formula works here. If I have f at s equal to u at x times v at x, product rule said, find the derivative of, it doesn't matter which one you find first because it's addition. Find the derivative of the first u at x, then multiply it by v at x, then plus find the derivative of v at x multiplied by u at x. Again, it doesn't matter whether you find the u at x derivative first or v at x. So here you can see the formula, u at x times the derivative of v at x plus v at x times the derivative of u at x. Or you can say u derivative of u at x times v at x plus derivative of again v at x times u at x. It doesn't matter whether you find derivative of v first or u first. But just let's look at the formula. U at x times v at x, the derivative of it will be u at x times the derivative of v at x plus v at x times the derivative of u at x, as we can see here. So let's see some example. So here we can see this is product. We have 2s cubed plus 3s plus 1 times s squared plus 4. So second question, this is a second question. So let's do the first one. So what I'm going to do, and you can see that this is more quicker than to open the parentheses because the derivative of 2x plus 4 will give me only 2x. The derivative of 2s cubed plus 3s plus 1 will give me only 6x squared plus 3. So you can see that at least instead of having 3 terms times 2 terms to make it longer, we're gonna end up having 2 terms times 1 term. So I'll always say use the derivative formula first. So we find that, so this is the solution here. We find the derivative of 2s cubed plus 3s plus 1, which will give us 6s squared plus 3. Then we multiply it by s squared plus 4. We find the derivative of s squared plus 4, which will be 2s. Then we multiply by 2s cubed plus 3s plus 1. So that's what we have here now. Then from here, we can open the parentheses and combine the like terms. So we're going to open the parentheses if no question. Well, let me wait here for a second if any question. Again, this is the question. Find the derivative of the first equation, multiply by the second. Find the derivative of the second, multiply by the first, and add the two together. So it's addition. We add the two together. So we multiply 2s by the 3 terms here, and we get 4s to the power 4 plus 6s squared plus 2x. Then we multiply the 2 binomial here, then we get 6s to the power 4 plus 3x squared, then 4 will give me 24x squared. 4 times 3 will give me 12. Then we look if we can combine any like term. Yes, we have 4, 6x to the power 4, and 4 to the power 4. So we can add these two. Then s squared, so we have 3 terms, 3, 24, and 6. Then the constant is only 1, and 2s is only 1. So we combine all the terms, and this is what we get. And that will be our final solution. Wait for a few seconds again. Again, we can see the formula. I'll multiply 2 items here. I'll find the derivative of the first one. I'll multiply with the second one. Then I'll find the derivative of the second one. Then I'll multiply with the first one. And I'll add the two together. So we're adding, this is the addition sign. We are adding the two terms together. We find the derivative of the second, multiply with the first. Then we find the derivative of the first, multiply with the second. Then we add the two together. So here we just combine the like terms, and that's the solution. If no question, let's go to the second B. So B, when you look at I will find the derivative of the first part, then I'll multiply it by the second part. So here I'll get 12x squared plus 10x minus 6 times x cubed minus 4x squared plus 1. Plus, then I'll find the derivative of the second one, 3x squared minus 8x times 4x cubed plus 5x squared minus 6x plus 5. Then we combine remove the parentheses. If you have any parentheses, then you combine the like terms together. So let's see how that works. So that's what we're doing here. We find the derivative of the second. We get 3x squared minus 8x. We multiply with the first.
Can you go back for a quick second, Professor? Okay. All right. Thank you. I'm good.
Yeah. So this is our first term. We leave it. Remember, this is our second term. So the derivative of this will give us 3x squared minus 8x. 1 is 0, constant. Then the derivative of this will give us 12x plus 10x minus 6. And that's what is here. We multiply by the first equation. Then addition sign is here. We add both together. So now this is our derivative. We can remove the parentheses. Then we combine the like terms. They say if we substitute s equal to, we find, let's see if the question said we should find the slope. Okay. So the second one, they say we should, at the point where s equal to 1, find the slope of the tangent line. So which means after we find the derivative of the function finish, remember this is multiplication. So we use the product rule to find the derivative. After we find it finished, we are looking to find the slope when at the tangent to the graph when s is 1. So I'm going to substitute 1 into the x to find the slope. So this will be, they say at the point where s equal to 1, find the slope of the tangent line to the graph. And we know if we want to find the slope of a tangent line, first we have to find the derivative of that function. Then the tangent line, the point where the straight line touches the graph, that point, x point, we substitute the x part of the point to find the slope of it. And that's what we did here. We combine these like terms together. So it seems like this is what we get. Then later we substitute s equal to 1 into f at x. We find the slope of the curve at s equal to 1, which will give us, again, the answer will be minus 72. Or if you like, you already find the derivative of f at x already. So if this is 1, you can just put 1 everywhere you see s, put 1, and then do your arithmetic operation, either multiplication or addition. You should get this answer. Or another option, remove the parentheses first, combine all the like term, then you substitute 1. Or substitute 1 straight to this function now and find the solution. You get the same answer. Okay, let's keep going. So we go to the quotient rule. And in the quotient rule, we also have different formula. But here we need to be very careful. You see the difference. We have minus. In product, we have plus. So 2 plus 3 is the same as 3 plus 2. So it doesn't matter which function you find the derivative first. But in quotient, it matters because 2 minus 3 is not the same as 3 minus 2. It is different. So here, always, just remember in your head, always you find the derivative of the top first. So the u derivative of u at x times v at x minus derivative of v at s times u at x, all divided by v square, v at s square. The v at s, you don't find the substitute. So you can see we have v at x all square. But at the top, you find the top derivative first. So we have v at s times derivative of u, because u is at the top denominator. Always that is first. Then minus u at s, then you find the derivative at the down. This is very important. So if you find the derivative of v at x times u minus, your answer is wrong. You get, it's like having one and negative one is totally different two values. The sign means something. So that's how the formula is. Always we divide by the square of the denominator. This is not a derivative, just the square of v at x. And again, that's the rule. So if no question, let's see an example. So we have two examples here. Sometimes also you may decide, for example, let's say if this question is s squared minus 4 divided by s plus 2. Well, if I want to, I will not even use, quotient rule because I can cancel the down. S squared minus 4 is the same as s squared minus 2 squared. So that we can use the difference of two formula, difference of two equation formula. So s squared minus 4 is the same as s plus 4 times s minus 2. And the down is s minus 2. So I'll cancel s minus 2 and s minus 2 out. So it will left with only what? S plus 2. So you just find the derivative of s plus 2. So what I'm trying to say here is that anytime you have a quotient, you want to find it, unless the question said, find the derivative of this function using the quotient rule, then that case, you cannot simplify the equation first. But if I'm going to find the derivative of a function and it's a quotient, if I can reduce it, we know we have a numerator and if the denominator can cancel the numerator to reduce it, I will do that first before I find the derivative. But when we look at this question now, the only option we have is to use the quotient rule. S squared minus 4s divided by s plus 5. We cannot cancel anything, so we have to use the quotient rule. Let's look at the second one. The second one also looks like we cannot cancel because this is 4 here. We can find the difference of the two, but we cannot cancel both from here. So the best way to solve these two equations is to use the quotient rule. So this is how it works. We find the derivative of s squared minus 4x, then we multiply by s plus 5. So here we get 2s, it will be 2s minus 4 times s plus 5, minus derivative at the down. The derivative at the down will be only 1, s plus 5 will be 1. So it will be 1 minus 1 times s squared minus 4x, all divided by s plus 5 all square. Then that's it, you finish. You can simplify the equation now using our algebra skills, either reducing the equation, factorize, whatever. Same thing applies to the second also. We find the derivative at the top, then we multiply with the down first. So we get 3s squared minus 6x times s squared minus 4 minus Derivative of x squared minus 4 will give me 2x. So 2x times x cubed minus 3x squared plus 2, all divided by x squared minus 4, all square. Then if you like, you can simplify the equation. Then we substitute. Here we are looking for the instantaneous rate of change of f at s when s is 3. So we substitute 3. The instantaneous rate of change, as we said, is almost the same concept as the slope of the tangent line. So we substitute 3 for s and we solve it. So let's look for the first one. This is our last example. So this is what we did now. We can see we find the derivative of the top. S squared minus 4s is 2s minus 4. The top first, numerator. Then I multiply by the denominator. The denominator is s plus 5 minus. Now I'll look at the derivative of the denominator. S plus 5 will give me 1. Then I'll multiply by the numerator, which is s squared minus 4x. Then I'll divide by everything squared, the denominator. The denominator is only s plus 5, so all square. Then here we just have to simplify it. So let's see. We decided to remove all the parentheses, and this is what we have. We're going to combine the like terms. We have 2 like terms here, so this is what we get. We can leave the answer like this, unless even if you remove s plus 5, s plus 5 will become a trinomial. It's difficult for the two to, unless you can see that the two can cancel each other. So in this case, I'll factorize the top. If I can factorize the top and get s plus 5, then maybe I can cancel. Other than that, you can leave the answer as it is. And this is the second one. So sorry first. So we can leave the answer as this. If I try to factorize this, I will get 2, and because this is 10. So I'll have to look for 2 values. When I combine, I will get 10. If I use 2 and 10, I cannot get 10. And if I use 4 and 5, I will get 9. And there's no any 2 values. When you combine, you get, when you multiply, you get minus 20. When you combine, you get 10.
Professor, for the derivative of x plus 5, why is it 1?
Yeah, because the derivative of s is 1. Derivative of a constant value 5 is 0.
Oh, okay.
So it's 1. So as we said earlier, those 3 first rules that we went through is what we are going to use throughout. So we know the power rule. We apply the power rule here because we have a s squared minus 4x. We apply the power rule. We also apply the coefficient with the variable rule also. And the third one is the constant. So those are the 3 basic derivative rules that we are going to use it for addition, subtraction, multiplication, division. Addition, subtraction is straightforward as we saw it. Multiplication, division, we have a formula for it. But after we write the formula down, we still need to find the derivative of some part of it, and we have to use those principles. So here we can see that we cannot reduce it. So if we cannot reduce the function, we leave it as our final solution. The B, the same process again. Find the derivative at the top first. The top was s cubed minus 3s squared plus 2. So the derivative will be 3s squared. 3 times 2 is 6. 2 minus 1 is 1. So it will give me 6x. Derivative of 2 is 0. So that's why we have 3s squared minus 6x. Then we multiply it by the down. The down is s squared minus 4, which is here. Now we find the derivative at the down. S squared minus 4 will give me only 2x. Derivative of 4 is a constant value, so that is 0. So we write the 2x. Then we multiply by the numerator, which is all the 3 terms here. Then we finish. So what we need to do now is to open the parentheses, see if we can simplify. But remember in this question, they say we should find the instantaneous value when s is 3. So here we can substitute the 3 for everywhere we see s, then we find it. But we decided to remove the parentheses first, then we combine the like terms. This is what we get. Now we're going to substitute with 3. So when you substitute the derivative of the function with 3, put 3 in all the s's and solve it, you get 33 by 25, which will give us 1.32. So instantaneous rate of change, first you find the derivative of the function, then the point they give you the changes at, you substitute that point into the function. It's almost same as finding the slope of a tangent line to the graph. So it's almost time. I'm going to end here. Oh, no, let's go. It's only one slide left. So let's just do this example. Then we know we finished 9 points. But again, I know in product and quotient, we need more practice. So even on Thursday after the quiz, we are going to do a couple of more questions that I will bring to the classroom. I mean, online here. Then we solve those questions. Maybe like 5 questions. Depends how much time we have. So we are not going to start 9.6 till hopefully next week, Tuesday. So here we have an equation. I don't want to read the question, but what is there is that they gave us a model about a medicine that we are taking or a person is taking. This medicine will change the blood pressure or temperature. And it's modeled by using this equation. First of all, when I look at the equation, I know this is a division, C by 2, M by 3. Even if I multiply M by everything, it's still a division, rational. So here they say C represents a positive constant value, and M will be the amount of the medicine that we absorb into our blood. And the rate of change of R with respect to M is the sensitivity of the body to the medicine. So the key word again is rate of change, derivative. So if this is a question they gave us, to find the rate of change, we have to find the derivative of the model or the function here. The question said we should find an expression for the sensitivity S as a function of M. So if that is the case, we say S will be what? dRdm. So we find the derivative of it using the quotient. So the rate of change is given. And again, as I said, we're going to do more examples on this quotient and product on Thursday after the quiz. So here we can just, again, substitute m squared times whatever we get. Normally, when I read this section, I may not explain because this is, again, pre-calculus, arithmetic operation. If you like, you can factorize it. Find the LCM. We have 2 fractions. It's up to you how you solve addition and subtraction. We find the LCM. So that's what they did, and this is what they got. And they combine. We have like terms here: m squared minus 2/3 minus 1/3. We combine 2/3 and 1/3 will give us 1. Since it's negative, we add them together and keep the negative sign. So we get MC minus MC squared. So again, from the model, we're finding the derivative of the function here. What is here is that you can see that m squared times. So we use the product rule. I find the derivative of this times this plus derivative of the fraction inside times m squared. So that's why you see addition here. So the derivative of here is what, let's go back again. The derivative of this, C is a constant value, so this will be 0. To be 0. So that's why we have 0 minus MT, m by 3 times m squared. We find 0, then we find the derivative of this. It's raised to the m, so m will give me 1. This m is only 1. It will be m, 1 minus 1. The exponent is 1, so 1 minus 1. So m to the power 0 give me 1. And we keep this is the coefficient rule. A coefficient of a variable, we always keep the coefficient. So this is where sometimes we have students, we make mistake. because we know the derivative of a constant value is 0, this is not a constant value because it's like 1/3 m. So it's a coefficient. 1/3 m is 1/3 coefficient for m. So we don't touch it. We leave the 1/3 m. But the rate of m is 1, so we keep 1/3. But if it should be like, okay, this is why this is 0. Why this is 0? Because c is not a variable. The question says c is a what? A positive constant value. So c, since c is a constant value, derivative of a constant value will be 0. 0/2, everything is 0. Or derivative of 2 also is 0. So that's why we get this. Now we find the derivative of m squared. M squared will give me 2m. Then I will multiply by the second variable, which is this. So what I'm saying, this is a product rule because we have multiplication here. M squared times derivative of this and derivative of what is in the parentheses times m squared. Addition, we had the two together. Then from here, we do our pre-calculus skills, combine the like terms, and this will feel like you can take m out to be m times c minus m. It's up to you. So this will be the conclusion of 9, section 5. And I'm going to stop the recording now. Hopefully, I'm going to post the recording in the classroom today, before the end of the day today.
Professor.
So,